Hello, everybody, and welcome to lesson 11-3, which is on your page 653. And it's multiplying binomials. And with this whole chapter 11, you're going to go back and forth between multiplying and adding and subtracting terms. And so you really have to be careful which operation you're doing. Right now, we're multiplying, but you will also combine like terms, which is adding and subtracting the same terms. So it's very hard to separate them. Binomials have two parts. So it would look like, for example, I'm making up an example, x plus 7. Remember, each part is separated by either a plus or minus, yeah? So that makes it a binomial. And the objective today is to multiply two binomials or a binomial by a trinomial. A trinomial has three parts, and it looks like this. For example, I'm making one up, okay? So you notice 1, 2, 3 parts. These parts are called terms often, okay? And each term is separated by a plus or minus. And so on the very first page, I'm skipping it. So we're going straight to the second page. We're going down here, problem 2, using a table. So I call it the box method. You will hear me say that. So that means table, yeah. And so what is a simpler form? Notice there's a binomial in the first parentheses and a binomial in the second parentheses. And between the parentheses is nothing, no sign, no plus or no minus. That means it's a multiplication dot. That means we're multiplying the first times the second. Okay, and it says use a table. So I'm going to write down some steps and you can follow those steps later on. So first you draw your box. And the box is a square, and I'm going to give you the advice to draw it pretty big. Because if you make it too small, it's kind of a mess in the end. You can't read your stuff because you got to write stuff inside the box. And I make it a square and I cut it into 4 equal parts, like a window. Now the first binomial, 3x plus 1, I put on top, but I make sure that I center it right above each square. The plus 1 stays together. Notice I put the sign that goes with the 1 I'm not putting the plus here, I'm putting it on the second bar. The second binomial I put on the side. X plus 4, the plus 4 goes down here. You can switch it off. You can put the second binomial on top, excuse me, and the first one on the side. It doesn't matter, okay? And then we're going to multiply. So the second step is multiply. So you go put your pen on the first box, you go up and over and multiply. So you multiply 3x times x, which is 3x squared, because you're adding the exponents, yeah? And you put your answer inside. Second, put your pen in the square, go up and over and multiply. 1 times x is positive 1x. Pen in the square, go all the way up and over and multiply. 3x times 4 is 12x. And then the last one, all the way up and over, you multiply. Watch your signs. Positive 1 times positive 4 is positive 4. Okay, so that's the second step. Then here, now we're switching gears. We're going to combine like terms. So that's when you add or subtract. So this one here and it's, so you have your first box, there's no like terms. I don't see any other x squareds here, but it's always this one, the diagonals that are like terms. 1x plus 12x. That's combining like terms. There's no multiplying. Do you see the dot here? None here. It's a plus. 1x plus 12x is 13x. So I'm going to start with the highest power. So my answer, I don't have a partner for 3x squared, so I'm writing it out. This is 13x. It has to be a plus because it's positive 13x. And the last one doesn't have a partner, so it's simply plus 4. Remember, you need to assign a plus or minus between each term. The answer is usually a trinomial. Usually a trinomial. Sometimes not, but 95%. Okay, so first we draw our box. We're multiplying two binomials. Draw your box, fill in the top and the side. How do you, I'm going over here. I'm reading this little thing. How do you use the given binomials to set up a product table, which I call the box, right? So you can say, put one binomial, and it doesn't matter which one, on top. And I'm saying include signs, the plus or minus, and 1 on the side. Include your pluses and minuses if they are minus, and here's our answer. All right, so that's the box method or the table. Make sure you pause the video if I'm going too fast. Make sure you have all your notes and listen to audio. Okay, make sure you do not just write what I'm saying, because also verbally I give you a lot of information. Next page, we're on page, oh wait, I don't have it. Practice. I think we only need to do one. These are minuses. It just didn't come out right. I'm going to rewrite this question. I want to show you how to do the minuses. So I'm going to rewrite it a minus 1 times a minus 11. Okay, two binomials, it's a multiplication. There's nothing between the parentheses, no sign. That means it's we're looking for a product. A product is the answer when you multiply. Okay, and we're using the box method. So again, first create box. Make it big. Don't make it too small. You have plenty of space here. What we have to write the binomials, a minus 1. Notice I keep the sign with a 1 and a minus 11 on the side. Notice I keep the sign with a number. That's important, otherwise you get messed up. Fill in the box or multiply. The first step is multiply. So a times a is a squared. Okay, so you put your pen in the box, up and over and multiply. Next box, next little square, negative 1 times a is negative 1a. Over here, up and over, negative 11a. Up and over, multiply, negative 1 times negative 11 is positive 11. Be careful with your signs. You see, negative times a negative is a positive. Combine like terms. Now we add and subtract. Plus or minus. You have to add and subtract like terms. You got to switch gears. So the first one is always usually alone. There's no other like term. It's the one that are in the diagonal here that are the same. See how they have an a? So those are like terms. Now we have to not multiply negative 1a plus negative 11a. That's an 11. So how many a's do we have? Negative 12a. Okay, so start for your answer. Start with the highest power, that's called descending order or standard form. There's no other a squared, so I'm writing it alone. This turns into negative 12a. And the number, the constant at the end, doesn't have a partner either, so that's my answer. And it turns out to be a trinomial again, which they usually are. Okay, next, we're going to the next page on the top. All right, so we're on problem 3. Now we're using a different method. You can watch this and say, I don't like it. I'm using box method. However you want. I prefer the box method I just showed you. This is another method to multiply. Choose the one you like. Choose, I think that's 2O, right? Either box or this is called foil method. Whichever one you prefer, okay? So when you see me and say, Ms. K, I don't get the foil method, well, then don't worry about it. You do the box method, okay? Foil, notice they're capital letters, stands for first, outer, inner, and last terms. So you foil, and it's a multiplying. Foil stands for multiply first, outer, inner, and last term. I want to write it pretty so you can read it. There we go. First, okay, so we have, what is the simpler form of each product? Product indicates multiplication. We're multiplying two binomials. Yeah, this is a binomial, 2 parts, and this is a binomial, 2 parts, and we're multiplying them. And we're using a second method, which is called FOIL, first, outer, inner, last. You do not have to use this method if you understand the box method. Okay, so we're going to make bows. I'm going to multiply the first term. So this is your first term and this is your first. So I'm drawing a bow. So 3x times x is 3x squared. Because you're multiplying two, so you're adding the exponents. 1 plus 1 is 2. So 3x squared is where I start. First term, outer term. The outer terms are this one and this one. I draw a bow to help me remember which ones they are. 3x times 2 is 6x. Plus, it's a positive 6x. Then comes the inner. I draw my bow below. These are the inner terms. Negative 4 times x is simply negative 4x. And then last. So the last terms is this one and this one. I draw my bow to guide me. Negative 4 times 2 is negative 8. All right, so I multiplied FOIL. Now I have to combine like terms. These two middle ones are like terms. So I'll call it multiply. And then second is combine like terms. All right, so again, I start with the highest power, which is the 3x squared plus 6x minus 4x is 2x. Positive 2x. And then the number last. And this is my answer. Okay. Here's our plan. I like these little things to help you remind what to do. How can a diagram, this is your diagram here, help you to multiply? Draw the bows. I call them bows like that, right? To guide you. Remember, it's first, outer, inner, last terms you multiply. Okay. Do I have another example on this? Oh yeah, I wanted to show you this harder one. It's a little difficult because you have numbers. Oh, you have p squared here, and p. We don't have that here. These are all linear. They're the first power. This is the second power. So we'll do this one. So we're going to do first, outer, inner, last. This is multiplying. Guide me with take the bow to guide you to the two first terms. I'll write it up here, how to multiply that. 2p squared times 2p. It's a times. Do you see the times button here? Not a plus or minus. So 2 times 2 is 4. Put a 1 here. This is p to the first power. So it's p 1 plus 2 is 3. So we start out with 4p cubed, right? First outer, the 2, draw the bow, 2p squared times -5. Notice the 5 is negative. The sign in front matters. That's multiplying here. 2 times -5 is -10. Attach the p squared. Inner, 3 times 2p is 6p, positive, and then last, 3 times -5 is -15, and now we're finished multiplying, but look, this is a third degree power, right? This is my degree 3, so it's going in descending order, which is called standard form, which is what we want, but there are no like terms. There's nothing that the variables have the same power, and this one doesn't even have a variable. So no like terms, so this is your answer. So you can box it or make sure you know this is how far we can go. This is called it's a polynomial with 4 terms. 1, 2, 3, 4. Each term is separated by a plus or a minus. No like terms to combine. So that can happen. And so next page is the one with the cylinder. I want to do this question, geometry. We're on page 657. Geometry, what is the total surface area of the cylinder? Write your answer as a polynomial in standard form. So what that means is you're not going to get an answer like 500 square feet or a number answer. It's going to be a polynomial in descending order, okay? The surface area is how much would you need to cover all the outside areas. Like the top is a circle, the bottom is a circle, and this is if you unroll it, if you cut this open and you would unroll it, what kind of shape would that be? That's going to be like a rectangle. So you have the top, bottom circle, and the rectangle area. So you have all those. And there's a formula for it. I'm gonna give it to you. It's S surface area is we need the area of 2 circles. So the circle is pi r squared times 2, because we got 1 circle, pi r squared surface area. Yeah, I found the volume. And then this, and the rectangle would be the height times the circumference. So the height of the rectangle times the circumference of this. When you unroll it, if you cut this open and unroll it, this circumference is the length. Circumference. and then times the height. And we have the height. The height is this, x plus 5. And this is our radius. And this is the height. Okay, I just realized I want to come back to this question at the end of my lesson because I need to show you one more thing before we can do this. And so we're coming back to this. Let me finish up with the surface area. So these are the two circles, right? Pi r squared times 2. And then we have to add this rectangle. So the circumference is 2 pi r. And then the height is x plus 5. Whoa, this looks really complicated, doesn't it? But we know the radius is x plus 2, so I'm going to plug that in. And then squared, and then times 2. And 2 pi r, we know that the radius is x plus 2. And we know, so this is my circumference. Circumference is 2 pi r. And yeah, so we have 2 pi times the radius, and then times the height. And the height is x plus 5. So I'm going to stop right here. So we need to multiply this out. We need to multiply this out, multiply it by 2 pi, multiply this part by 2 pi. So I'm going to rewrite it real pretty. I'm going to move this 2 out front. 2 pi times x plus 2 squared. So this 2 I just moved in the front. Plus, this is a plus, not multiplying, 2 pi times x plus 2 times x plus 5. Actually, I don't have to show you that other part. I just realized these are just two binomials. So I'm going to rewrite again, 2 pi times x plus 2. This right here is often mistakes. Students want to shower the power. You cannot shower the power because of that plus. So how that looks, it multiplies the base by itself. That power of 2 tells you multiply the base twice, and the base being x plus 2. So be careful. I'm going to write that up here. X plus 2 squared is not, no, it's not x squared plus 4. No, not a good idea. Okay, so you have to rewrite it twice. Plus 2 pi, then x plus 2 times x plus 5. These two you need to multiply out using the box method. I think I can factor out the 2 pi because we got that on both. The box method for the first x plus 2 times x plus 2, which is x squared plus 2x plus 2x plus 4. These are like terms. So we have x squared plus 4x plus 4. So we have 2 pi times x squared plus 4x plus 4. This multiplied out, I'm going to speed it up a little bit. I'm just going to do this in my head. This is going to turn into, when you use your box method, it's going to turn into x squared plus 7x plus 10. And then we can, from here, I could distribute. I'm going to stop right here. I have to think about how we're going to make that shorter, because I don't think that's, I think that's too lengthy. We can make it shorter by factoring out, but I'm going to have to think about that for a second. I'm going to stop for a minute and go on to the next page, which is what I wanted to show you, multiplying a trinomial and a binomial. Okay, so the first, you notice we have 3 parts here, trinomial times binomial. That's what this comes from, right? And it's timesing. So the way we're going to do it is we're going to use the box method again, because for me, it works better, all right? It's more organized. Whoops, what happened to my tools? There we are. But because it's a trinomial, I'm going to have to build, oh, I got a different color. I'm going to have to build a much bigger box. It's going to be a long rectangle. And I cut it in half this way. And then because it's a trinomial, I cut it in 3 parts like that. So the trinomial, I'm going to put that on top. If you want to change the box and make it lengthwise and put it on the side, that's fine too. +1, and then the x minus 3 on the side. So you're just making your box a little bit bigger. Again, we're going to multiply the box out. So I'm going to go up and over and multiply. So 2x squared times x, yeah, up and over, you're multiplying. So that's 2x cubed because you're adding the exponents. All right, next one, negative 3x times x is negative 3x squared because you're adding the exponents. We're multiplying powers, add the exponents. Plus 1x. Down here, 2x, so you're going up and over, you're multiplying 2x squared times negative 3, negative 6x squared. Go up and over, oops, negative 3x times negative 3 is positive, a negative times a negative positive 9x. And last one, 1 times negative 3 is negative 3. So you fill in your box, look for your like terms. The 2x cubed has no partner. That's my highest power. But these diagonals usually are partners you can combine. So now we're combining like terms again. So first you multiply. Combine like terms is adding and subtracting. So you don't add your powers, your exponents. Okay, you only add your numbers in front. Negative 3x squared minus 6x squared. Notice how those are like terms, the same variable raised to the same power, and we're adding or subtracting. Only write the power once, minus 9x squared, and then plus 1x, this one, plus 9x. Like terms, we're adding, it's simply 10x. Last is the number. It's a 4-part answer, 3, 2, 1, descending order. This is my answer. Okay, that's the box method when you're multiplying a trinomial by a binomial. And then let's go over the homework real quick. And I'll come back to that problem. Homework is on page 659. So you're simplifying. A product means multiply. So you're going to do the box method most likely. If you like it, I like it. But you don't have to, you can use FOIL. So I'm going to write that. Use box method. Oops. Or FOIL, whichever one you like. Okay. Number 12. Then this is a bigger one, right? This is a big box. If you use the box method, you want to make it like that. The x plus 2 comes on this side. And then the x squared plus 3x minus 4 goes up here. So that would be binomial times a trinomial. Then number 14. See if you can make sense out of that. A rectangle has a length of x plus 5 and a width of x minus 3. What is the area? Area is length times width. So you need to multiply these two. Write your answer as a polynomial in standard form. That's what all of these answers are. Next page, we're going to do a few practice problems. So you might have a few extra questions, but those are the things you have to practice to get good. 15, explain how to use the FOIL method. How to use the FOIL method. So you want to explain what FOIL means, okay? And then on the next page, up here, these are all practice problems. So you need a paper probably to write them. So, or you can find room somewhere, but that's a lot of work to be shown. You can use your box method or FOIL. There's an error. And I think that's it. Wait, do I have this one? Surface area. Yeah, I wanted to do number 29. Each expression, so we don't do 30 or 31. Represent the side length of a cube. Write a polynomial in standard form for the surface area. So kind of like this. You have a cube, like a dice. How many faces does that dice have? You're adding up the area of all 6 faces. So you're really just finding the front and then multiply your answer by 6. Side length is x plus 2. So if you have the front, if you have a side length of x plus 2, and this is x plus 2 because it's a cube, you need to multiply these two. And then you multiply your answer by 6 because you have 6 identical side faces and it's the surface area. Okay, pause the video. So I came back to that cylinder question to finish it up. We stopped right here and I looked at it and we have 2 pi and we have a plus. So that means both parts have the same GCF, greatest common factor, which is the 2 pi. So I can factor that out. And it turned, when you factor it out, you divide by it. I skipped that step. Don't worry if you're lost already. Some people might go, oh yeah, now I get it. But if you don't worry about it. The 2 pi I put out front. When I divide by 2 pi, I put the rest in the parentheses and I can add these two because it's a plus right here. So I have the plus now here. And when you combine like terms, you got x squared plus x squared is 2x squared, 4x plus 7x is 11x, and then the 4 plus the 10 is 14. And that is as far as we can go. So this would be the surface area in as a polynomial in standard form. All righty, guys. See you next time.